Okay, so a quick question that comes up a lot, and so quickly want to run through it just so everybody can see what's going on, would be for a problem like this. So I'm going to solve it using elimination technique. So the first thing I'm going to do is say, okay, I need to eliminate a variable. I'm going to do x's because they look easy. So I'm just going to multiply through my first equation. I'm going to multiply through by -2. So I multiply both sides by -2. So that way I end up with -6x plus 8y equals -18. And that way I have a -6x and a +6x. So when I add them together, I'll end up getting a 0. Now, the problem here is when I do this, the -6 and +6 give me my 0, but now I have the same thing. I have a -8 and a +8y, so I end up getting 0. And here's the key part here is when I add together 18 and -18, I get another 0. So what this is telling me is 0 equals 0. And because this is a true statement, it means I have infinitely many solutions. But the trick here is we don't get to just write infinitely many solutions like we used to in other classes. We're actually going to have to put it in some form of math notation that is a lot less fun nowadays than it used to be. So what I'm going to do when I get this infinitely many solutions, what it's telling me is they're the same line. You notice that when I multiplied this line by 2, it came out to be the same values. So if I were to graph them, and I encourage you to graph both lines, and you'll see they look identical. They're on top of each other. And I can simply change this equation into the other one by dividing by 2. So when you have this type of situation, we're going to write it in a slightly special way. So here we go. So what I'm going to do is take our equation, 3x minus 4y equals 9. And how WebAssign is going to have you write your answers is typically they say in terms of blank. Now the blank can be filled in with in terms of x, or maybe in terms of y, or if there are more variables it could be z, w, whatever. So I will start with it in terms of x. So what this is saying to you is to do the following. And the other notation they like to use is they'll remind you that in terms of x is the same thing as y as a function of x, meaning you pick a value for x and it'll give out a value for y. So this is just code saying solve for y. If you solve for y, you'll get it in terms of x. So I'm just going to take this equation and solve it to be in terms of y. So I'll subtract 3x from both sides, which will give me -4y equals -3x plus 9, and then I divide by -4. And now I have y equals 3/4 x minus 9/4. So now I am ready to write my answer. So the answer is still written as an ordered pair, just like it would be if this problem had a solution, okay? Except it's in terms of x. So meaning x just gets to be x. So in that part, in that spot in the ordered pair, we're just going to put an x. But over here in the y, we don't want to write y's. We want to write x's. So everywhere I have a y, I'm just going to replace it with what y is equal to. 3/4 x minus 9/4. So this right here, you are looking at your answer. That's the answer right there in terms of x. What if they gave us the same problem but instead asked for it in terms of y? Well, so then we start with the same equation. It doesn't matter what form it's asking for it in. We're still going to have our original equation. So, but instead of being in terms of x, if they want it in terms of y, that means you put in y's, you're going to get out x. So our function notation would look like that. So again, now we're just going to switch what we're solving for. Instead of solving for y, now we're going to solve for x. So same process. I will pause the video and jump to the answer. There we go. So now you can see the answer is going to be written in terms of y, meaning you pick a y and I'll spit out an x. So therefore, our ordered pair would be written as 4/3 y plus 3, comma y. Okay, so I hope this helps you make sense of those problems. Just be very mindful of what they're asking for the problem in terms of. And when you get to these problems that are much larger in the next section, you're going to see you're going to have x's, y's, z's, w's. And so if we're doing them in your graphing calculator, it's a thought exercise. You have to think about how would you get it in terms of x and y, because the calculator's not going to spit them out in a way that's easy to do that. So if you get a little creative with how you type in the calculator will give you your answers in the right terms, and it makes it very much more simple. Okay, best of luck. Enjoy the video.